Hey guys, so this video series is going to be the different genetic syndromes that you can get with colon cancer. And I'm going to explain what happens, and then I'm going to give my sayings to help you remember. So hopefully this helps somebody. So the first one is Peutz-Jeghers syndrome, which I'm not really sure if that's how you pronounce it, but that's what I'm going to call it. And so what happens in this syndrome is you have this pathway. So you have LKB1 and STK1. They're your genes that activate AMPK. When you activate AMPK, its job is to stop the mTOR complex from forming. So it's going to inactivate mTOR, which is a good thing because what mTOR's job is to do normally is to activate cell proliferation. And we don't want that, or we'd have cancer everywhere. So that is the normal function. If we get a mutation here at the top in LKB1 and STK1, then the result is mTOR's activation is going to go through the roof. And we're going to get all kinds of cell proliferation, which is what we don't want. So the way we remember this is Peutz-Jeghers is my weird cowboy. And he likes steak. So this is my steak. It's a horrible drawing, I know, but bear with me. So he likes it. So he LKB1. He likes STK1. He likes steak. He's a cowboy. Of course he likes steak. So what do you yell out when you're trying to call a bull? You yell out Toro, meaning what's constantly active when we mess this up? mTOR. So if you just remember Peutz-Jeghers, he likes steak, and so he has constantly activated mTOR. And to remember the amped part, he really likes steak. He likes steak so much that it gets him amped. So that's to fully remember your pathway. He likes steak so much that he's amped, okay? I don't know, make him Canadian at the end. He's amped, okay? And then you are going to end up with constant activation of mTOR. So you have LKB1, STK1, AMPK, and mTOR. Those are your things involved in this syndrome. So the next one that we are going to be doing is going to be juvenile polyps. Okay, so this one's a little bit more of a story. So first we're going to talk about the pathway. So it is the TGF-beta and BMP pathway. And what that means is your genes involved are going to be BMP, R1A, and SMAD4. And these are your two big players in this pathway. You don't need to know the specifics of the pathway. Just know those are your two big players. And their function normally is to repress MYC. And MYC, what it functions as is a receptor for growth and proliferation. So it is a receptor. You'll see it other places. You'll see it referred to as c-MYC a lot of times, and that's really common in your pathways for melanoma, where you will see c-MYC is the receptor tyrosine kinase, and then you go down the RAF-MEK-ERF pathway of your receptor tyrosine kinase pathway. But I digress. That's the main thing. It's MYC. MYC is all about proliferation. So to do that, MYC is going to turn up your cyclins and turn down CDK inhibitors. That's what MYC would do, but you're repressing it from doing that. However, you get a mutation in these, and that's out the window, and you end up with juvenile polyps. So here's our story, and we have this little juvenile. So it's a little kid, and he's totally bleeping SMAD. And the reason he is totally beeping SMAD is to remind you TGF-beta. Beeping is your BMP R1A. So he's totally beeping, and then SMAD4. So those are your mutations. So why is he totally beeping SMAD? Well, he wanted to see Mickey. So yeah, there's Mickey Mouse, and he's on a cycle. So he wanted to see Mickey. So if you get mutations in these, you're going to get increased MYC, and that's going to increase your cyclin. So Mickey's on the cycle, and he's going up. So everything over here is going up. So, but what's this little kid's name? I didn't give him one yet. His name is just initials. He goes by CDK. And CDK is depressed. So he's down. So we're going to draw him an arrow to show he's depressed. But Mickey's happy. So everything here is going up. So the main point is totally beeping SMAD. So TGF-beta pathway, where your main genes are going to be BMP, R1A, and SMAD4. They get mutated. When that happens, Mick goes up and cyclin goes up. So Mickey's happy, everything's going up. And then CDK, he's depressed, he's totally beeping SMAD, he can't see Mickey, he goes down. And that's what happens with juvenile polyps. Okay, so our next syndrome is Cowden syndrome. And so we have to understand this pathway a lot in order for this one to make sense. So you have your receptor tyrosine kinase, your RTKs, and going down that pathway, eventually you're going to get to PIP2, which is going to become PIP3 in order to activate PKB. And this is going to end up in growth. Receptor tyrosine kinases are often involved in growth and proliferation. So, in order to stop this from just going and going and going and making a ton of PKB, you have P10. And P10 comes in here, and it's going to take PIP3 back to PIP2. That's its function. So a mutation in P10 would mean you could just keep going and making PKB forever. We don't want that. Okay, so how are you going to remember this pathway? How are you going to make it make sense? Well, I think of it this way. I have my RTINK, or RTK. So my RTINK is Tinkerbell. And Tinkerbell, she's really, really fat here. And she's so fat because she's using all her magic to make Peter Pan peanut butter. How does she do that? Well, she takes PIP2 to PIP3. So she is growing peanut butter. And she's making those peanuts grow. So they're going from 2 to 3. And then she makes PKB, or as I call it, Peter Pan peanut butter. So that's the point. So you're going from RK to PB. And she does it by going from step 2 to step 3. So she's step 1. Tinkerbell is step 1. And then you do 2, 3. So you're going to go PIP 2, PIP 3. Simple as that. So Tinkerbell, PIP 2, PIP 3. She's made peanut butter, Peter Pan peanut butter. There's your normal pathway. So then you have Peter Pan. He's over here. And he goes, "You fat cow, I don't want to grow up." So she's making this grow. She's going from 2 to 3. He doesn't want that. Peter Pan never wanted to grow up. So Peter Pan takes you back. He takes you back from 3 back to 2. He doesn't want to grow up. And he's yelling out, "You fat cow," because this fat Tinkerbell is making all this peanut butter and he doesn't want her to. So that's the idea. So just to go back, you have RTK. It's going to cause PIP2 to PIP3 to PKB. If you continue to do this, you're going to have growth and proliferation. Peter Pan doesn't want you to grow up, so P10 is going to come in, and he's going to take you back from PIP3 to PIP2. And it's Cowden syndrome. Remember, it's your fat Tinkerbell. So he's yelling at her, "You fat cow!" So that's the story of Cowden. So continuing on our journey, our next one is familial adenitis polyposis. And this is a syndrome where these people will have tons of hundreds of polyps. It's called FAP. And what happens with FAP is you have APC, which normally will inactivate beta-catenin. And beta-catenin regulates MYC. Our old friend who causes proliferation is back to haunt us again. So that's its normal function. So if you were to have a mutation in APC, you could no longer activate beta-catenin. It's a hard word to say. Anyway, you could no longer inactivate it, and therefore you would have MYC active all the time. So, how do I remember this? Well, this is FAP. And who is more FAP or FAD than Michael Jackson and Mickey Mouse? And so we had little kid Michael Jackson with Mickey Mouse, and they're singing APC. It activates beta-catenin. And that's just to remind you that when you're FAP or FAD, like them, that's what normally happens. APC inactivates beta-catenin, which would turn on MYC. get a mutation in APC, you have beta-catenin go up, you have MYC go up. It's as simple as 1, 2, 3. Yes, that was a pun. Okay, next disorder. There's not much to say about this one. This one is hereditary non-polyposis colon cancer, which means you don't have polyps. It's also known as Lynch syndrome. And what's mutated here is MLH1 and MSH2. They're mismatched repair genes. And what that means is if you were to get a mismatch in your base pairs, then these genes would be responsible for the repair of your DNA. If you have a mutation in them, you can't repair your DNA, you're more prone to cancer. And honestly, with this one, MLH1 and MSH1 look like the word mismatch. So I just remember that's what they go for. So they're the mismatch genes. And the way I can remember they go with this disorder is to have colon cancer but not have polyps seems like it doesn't go together. So it seems like a mismatch. And just think, if you were to get something wrong, people might lynch you. So there you go. That's how you remember this one. Okay, guys. So finally, our last one. This is your sporadic colon cancers. And for this one, we go back to our old friend, APC. So you mutate your first APC, then your second hit is going to hit the other APC. And remember what APC normally does. It inactivates beta-catenin. So if you mutate your second APC, now you're going to get activation of beta-catenin, which we talked about is going to upregulate MYC. The next thing is going to be KRAS. And then finally, your late things are something you'll see in most all tumors. P53, occasionally you'll see SMAD, and then telomerase, which is something you're going to see in almost any tumor. So here's how I remember this. So you are just sporadically singing the ABC song. You're sporadically going APC. It activates beta-catenin. And you sing it twice to remind you your first hit is APC, and then your second hit is APC as well. So you're going to go APC, it activates beta-catenin. APC, it activates beta-catenin. And when you do that, someone's going to look at you and go, well, that's awfully crass. And that's going to be your next mutation. And then finally, just remember your late ones are stuff you see in all cancer. P53, SMAD, telomerase. And the last point that's important to remember, it can take 7 to 10 years for this adenoma to become adenocarcinoma and to go through all of these transformations, to go from the normal colon to a full-on adenocarcinoma. This is why when you have someone who has a polyp, you're going to begin screening them every 5 years for colon cancer instead of the normal every 10, because it's going to take 7 to 10 years for it to become cancer. Hopefully this has helped you guys. Just went through all of these in about 13 minutes. Let me know if this is helpful, and I'll keep doing it.